In this video, we're going to look at two examples on how to solve absolute value inequalities. So the first example we're going to do, it says solve the absolute value inequality using an equivalent compound inequality. Other than the empty set, use interval notation to express the solution set and graph the solution set on a number line. Okay, so we have 5 plus the absolute value of 1 minus x over 2 is greater than or equal to 8. Because this is an absolute value inequality, the first step we will need to do is to isolate the absolute value. In this example, in order to isolate the absolute value, we're going to subtract 5 from both sides. So we have the absolute value of 1 minus x over 2 is greater than or equal to 8 minus 5. Okay? Which gives us the absolute value of 1 minus x over 2 is greater than or equal to 3. So now that we have the absolute value on the side by itself, we need to use our definition of absolute value inequality. So in this example, in order for us to get rid of the absolute value, we're going to use the definition that says we can rewrite without absolute value 1 minus x over 2 is greater than or equal to 3, or 1 minus x over 2 is less than or equal to negative 3. So doing the first one, where we have 1 minus x over 2 is greater than or equal to 3, we're starting to solve for x, so let's get x on the side by itself. So the first thing we would need to do is to subtract 1 from both sides. So we have negative x over 2 is greater than or equal to 3 minus 1. So now we have negative x over 2 is greater than or equal to 2. So the next thing I'm going to do is to either, you can say multiply by a negative or divide by a negative. But whenever we do either one, we would have to also change the direction of the inequality. So we have x divided by 2 is less than or equal to negative 2. And the last step is to finally get x on the side by itself. So in this example, we're going to multiply both sides of the inequality by 2. So we have x is less than or equal to negative 4. Okay. So now, applying the other part of the definition, we still have to solve for x, meaning getting x on the side by itself. So let's subtract 1 from both sides. So we have negative x over 2 is less than or equal to negative 4. And at the same point again, we need to either multiply by a negative or divide by a negative, therefore changing the direction of the inequality. So we have x over 2 is greater than or equal to 4. And now let's solve for x. So we have x is greater than or equal to 8. Okay. So now we need to express the solution in interval notation. So in order to express that x is less than or equal to negative 4, we're coming from negative infinity and we're stopping at negative 4. And since we have a greater than or equal to, in this case, a less than or equal to inequality, we will have negative infinity to negative 4 with the bracket. Or expressing x is greater than or equal to 8, so we're going from 8 to infinity. We will have a bracket at 8, and we're going to infinity. Okay. So now let's express the solution on the number line. So let's plot our negative 4. Plot our negative 4, and we're going to plot our 8. So to answer the inequality from negative infinity to negative 4, we're going to put a bracket on negative 4, and we're coming from negative infinity, so your arrow will go to the left. And for 8, we will put a bracket on 8, and we're going to infinity. Okay? So now, the next example that will involve an absolute value and an inequality, it says solve the absolute value inequality using an equivalent compound inequality. Other than the empty set, use interval notation to express the solution set and graph the solution set on a number line. Once again, we would need to isolate the absolute value. So we would have the absolute value of 3x plus 2 is less than, and we're going to subtract, in this case, we're going to add 4 to both sides. So we have negative 7 plus 4. So we have the absolute value of 3x plus 2 is less than negative 3. And based on your definition, this inequality with the absolute value is not set up correctly to apply one of the definition, which says the absolute value of u is less than a. In this example, we have the absolute value is less than a negative value. So the solution to this would actually be the empty set.